Welcome to the thermodynamics unit. We're going to go ahead and take a look at everything that this unit has to offer. And the main focus of this unit is going to be energy and how energy is related to chemical reactions. So far, we've taken a look at chemical reactions in terms of products and reactants and all that. Well, now we're going to really focus on the energy. So now the question is, what exactly is energy? It says energy is the ability of a physical system to perform work. So we can have energy in a bunch of different ways. We can have chemical energy, we can have radiant energy, electrical energy. There's all kinds of different kinds of energy that can do work. Okay. One thing we do need to understand is the first law of thermodynamics. It's very similar to the law of conservation of mass. That says the first law of thermodynamics says that energy cannot be created nor destroyed. However, it can be transformed. So let's take a look over here for a moment. I can take chemical energy in the form of food and I can change that into motion. Okay, I can take radiant energy and I can change that to chemical energy. Okay, I can change electrical energy into thermal energy. So I can transfer energy. I just can't create it, nor can I destroy it. So, as you should already know, there's two main forms of energy. We have kinetic energy and we have potential energy. So let's go ahead and take a look at kinetic energy. You should already know that kinetic energy is the energy of motion. And we can calculate that in terms of this formula right here, which is kinetic energy equals 1/2 mv squared. And m stands for the mass. This mass is going to be in kilograms. And v is going to be the velocity in terms of meters per second. Now, when we do that formula, it's going to end up giving us this unit. Okay, now we're not going to always say that unit because that's got a lot going on. What we're going to do is we're going to simplify that down to the joule. Okay, and a joule is basically this unit right here. Okay, another important thing to remember is that the higher the temperature you have, the more movement there is in a substance. All right. Um, Now, when we're thinking about energy, a lot of times we're also thinking about heat. All right, and heat, we're a lot of times going to represent heat with this variable Q. Q is going to represent heat. This is also known as thermal energy, and it's also going to be a transfer of kinetic energy from a higher temperature to a lower temperature. We're going to take a look at ways that we can transfer heat. These are some good definitions for you to know. You should know these definitions certainly for a test or a quiz. Conduction is where you have like a long piece of metal, all right? And basically, right over here, a metal atom is going to heat up, all right? And so this atom is going to heat up, and then it's going to cause the atom next to it to heat up. And then that's going to cause the atom next to that to heat up, and so on and so forth, okay? And so that heat transfers along our metal rod by heating up the atom directly next to it. Okay, that's conduction. Convection would be this example right here. Okay, convection is where you have a transfer of heat through a fluid, either a liquid or a gas. Okay, and so this can be caused by the circulation of or movement of molecules. And a good example of this is when warm air rises or cool air appears to fall in a room. We can also experience radiation, which is energy that's transmitted in the form of waves. Okay, and that's going to be like energy of the sun. The last form of energy that we're going to talk about is potential energy, and you should already know about potential energy from your middle school science classes as well. Of course, we remember that potential energy is going to be stored energy, meaning that it's storing that energy, waiting to be able to use it. Okay. Now, in physics, this is generally going to be described as the position of an object in relative to where it could possibly be. All right. However, in chemistry, we're going to focus on potential energy being in the forms of bonds or the lack thereof. Okay, this can also be in the form of intermolecular forces. So what we would say is that energy is released when bonds form. Okay, so if I have two atoms, I stick those atoms together to form a bond, it's going to release energy when those bonds form. Okay, we generally see that in terms of an exothermic reaction. Energy is required or taken in order to break bonds. So if I have a bond and I break that bond, or I have two new substances or two individual atoms, it takes energy. So it's an endothermic reaction when we break bonds. Okay, it says that the potential energy that is stored in the bonding structure can be transformed into other chemicals, heat energy, light energy, or even mechanical or electrical energy. So, for instance, right here, this little gummy bear has stored energy in it. When we break these bonds down, it's going to release that energy in the form of heat, in the form of light, and so on and so forth. That's going to be that for this section of the notes.